The question is, if you assume that the AB, point AB, are the intersection between the x-axis and the quadratic function y is equal to 8 times x squared minus 4x plus 3, and point C is a vertex, then the area of the triangle ABC, which we're going to be made by our points A, B, and C, becomes 4. In our ultimate question, we're going to be solve for the A when it is a positive value. So this question is basically asking us to solve for the area of a triangle that is formed by the 3 points A, B, and C on the coordinate plane. And there are 3 solutions that we have in order to approach these questions. As a first solutions to approach these questions, let's think about our first solution, which means we need to think about the types and definition of our vertex in a quadratic function. And luckily, the 2 types of our quadratic function were going to be defined by our leading coefficient in our quadratic function A. And let's go back to our basic format of quadratic functions, standard form, to think about remind ourselves what is A and think about what does each variables in the quadratic function defines. The standard form, which is the most basic format in our quadratic function, will be y is equal to ax squared plus bx plus c. So let's think about what this each variable defines or does. So firstly, let's think about y and x. Y should always be the output. X should always be the input of our function. And we could say that this output and input values are technically defines or makes our function. And secondly, let's think about what is our A. As we can see, the value A we're going to be a leading coefficient. So A is a leading coefficient. And if you think about the difference between just a coefficient and the leading coefficient, we're going to be defined by our word leading. Leading is a short form to refer to our highest degree power term in our quadratic function x squared, which means the coefficient of the leading term, which we call it as the leading coefficient, we're going to be our A. And that A defines our types of graphs as well as our vertex in our quadratic function. Now let's think about other things. Let's think about what is B secondly. B is exactly the same kind of concept with the A, except it is just a coefficient. It is a coefficient of first degree power x terms. And lastly, let's think about what is our C. And C will going to be our y-intercepts in our quadratic function. And if you don't know what the y-intercept will look like, if you convert this into some specific format as well as the coordinates, you are going to be 0, y. Which means when our input value, our x value exists, and that is equal to 0, our output of our function, which we call it as the y or f of x depends on times, output will exist. And the reason why we just notate it as the y value, not a specific value, is because we know that x and the y are variables, which means the changes depends on times. The first thing that we did here is thought about what this each constant does. And if you don't know what the definition of the constant is, it is a number. It is an isolated number, unlike the coefficient. Because the coefficient is a same thing with the constant, except it is beside our variable. But the constant in this case itself will gonna be the isolated numbers with no variables, unlike the coefficient. And now let's think about, to be more specific, let's think about our 2 types in our quadratic functions vertex. So for the first case, we know that all of the cases in the vertex will be defined by our leading coefficient A. And it is a signs. When the A value, our first case, when our leading coefficient is greater than 0, which means when it is a positive value, the graph of every quadratic function will opens upward. And when the quadratic function's graph opens upward, for example, it will look something like this that keeps going toward upward, and it will contain one most important point in the quadratic function, which we usually notated as the minimum, or we also notate it as the lowest point on the graph. Now let's think about what the second case will be. The second case of our quadratic function's graph vertex will be defined when the a value are linear coefficients at less than 0, which means when it is negative, the graph of our quadratic function will open downward or go downward, unlike the first case where it went upward. And obviously the graph will be opposite with our first case, and it will look something like this that keeps going toward upward, not upward, downward, and it will contain another most important point in the quadratic function, which is a maximum point, also the highest point on our graph. And from the types of our vertex, we can think about the definition of our vertex. So the main definition of our vertex we're going to be the addition between the number of possibilities between the minimum or the maximum point on our graph, which we're going to be defined by our signs of A. And this is a thing that makes or generates our vertex. We talked about our first solutions, types, and the definition of vertex in the quadratic function. And now let's think about the second solution to approach this question, general types of quadratic function forms. If we think about what the standard form is, it is a y is equal to ax squared plus bx plus c. And basically it is a most basic format in our quadratic function, and it is optimized for the calculations, which means it is a simple format, so it is easy for us to calculate to solve for the missing variables or other output or inputs, as well as the constants. And for the calculation, there is the main example we're going to be our y-intercept in this standard form. But if you think about the one bad thing about our standard form is, it is good for us to calculate something, but we can't solve for the vertex. So that means we won't be able to solve for our graphing the parabola, because there is no other way to solve for our vertex, which is x comma y. In order to solve for our vertex, we need to convert this into some specific formula. So we need to apply our formula, or we need to convert standard form into some specific forms to solve for our vertex. So this is one inconvenient thing about this standard form. Now let's think about the second one, and the second one we're going to be a binomial form with a different corollary. For a binomial form, it is optimized for solving for the x-intercepts, because it is formed by the x-intercepts. And one thing good about or convenient about binomial form is we know that the vertex is the most important thing for solving for a graph of our quadratic function, and it is formed by x comma y, where x is the input and our output of our function is y. And the only good thing about binomial form is we don't have to convert this into some specific form or apply our formulas, unlike the standard form, because the x in our vertex, it is same thing with the average or mean, the average of two x-intercepts. This is what the x value of our vertex is, and this is one of the convenient properties of our binomial form. And since we solve for the input, all you have to do to solve for our output is input into the function or the equation that we contain, and it will going to generate some specific output, which we call it as the y or f of x. And this is about the binomial form. What is it optimized for? Form of a quadratic function will going to be a vertex form. Y is equal to a times x minus p squared plus q. And obviously we can see from its name, it is optimized for solving for the vertex. So basically it's optimized for solving for the vertex of our function. The reason because we know that vertex is formed by x, y. And in that vertex, the p here will going to be our x coordinate of our vertex. And the q here, which is a constant value in our vertex form, will going to be our y coordinate of our vertex. So that's why vertex form is optimized for solving for a vertex with its constant q, p, and q. And this was the second solution where we talked about the general types of quadratic function form, and there were basically three forms: standard form, binomial form, and vertex form. There are a lot of things that it is optimized for solving stuff. Firstly, let's write our function down as a in order to approach this question, and our function we're going to be y is equal to 8 times x squared minus 4x plus 3. We can see our ultimate goal in this question is to solve for the a value. And the given information is that our triangle ABC, first of all, let's think about in split one. It is same thing with just a point A, point B, and the point A to the point B. This one will going to be the x-intercept according to the information from the question. And if you think about what the C is, C will going to be our vertex of our question. And they said A, which is our leading coefficient, is greater than 0. So our a is greater than 0, which means our graph of a quadratic function, in this case, will opens upward. And the c value, which will going to be our vertex in our quadratic function, will going to be a minimum point on our quadratic function, or the lowest point on our graph. From here, we can think about the last solution to solve this question: formula for the area of triangle on the coordinate plane. So, formula for area of the triangle on the coordinate plane. And the area of a triangle or the area of a triangle on the coordinate plane is exactly the same. So, the triangle area will going to be baseline times height times 1/2, or divided by 2. This is what the area for the triangle will going to be. So we can see that AB, the segment AB, will going to be the base, and then times height, and the height will going to be C, which will going to be vertex, and if you multiply 1/2, we'll be able to solve for the area of our triangle. Firstly, let's think about how to solve the baseline, which will going to be the A and B. So firstly, let's think about A. And from here, we know that this is a standard form. In order to solve for the so this is standard form. And in order to solve for our x-intercept, as we learned in the first solution, all you have to do is convert standard form into a binomial form, which is optimized for solving for the x-intercepts. So we're basically converting standard form into a binomial form to solve for the x-intercepts, to solve for our baseline A, B. So if we convert our y is equal to 8 times x squared minus 4x plus 3 into a binomial form, we'll be able to get y is equal to a. So we can write the color. So our original standard form, which is the most basic format of quadratic function, was y is equal to 8 times x squared minus 4x plus 3. But if we convert this into a binomial form, we're going to be y is equal to 8 times x, so x minus 3 times x minus 1. What we did here is we convert our standard form into a binomial form. And from here, we'll be able to solve for a and b. So a and b can be either 3 or 1. So I'll just randomly put a as 3. But then if you convert this into a coordinate, we're going to be 3, 0. Our b, we're going to be 1, 0. This is what the x-intercepts. It is what x-intercepts in our quadratic function we're going to be. Now, in order to solve for a baseline, we need to think about the lengths between a and b. And the lengths, as we have learned, lengths on the coordinate plane, there is no negative. Which means, in order to solve for lengths on the coordinate plane between points, it will going to be a differences between the points. Which means the lengths in this case, between 3, 0, and then 1, 0 according to the property, the only difference between them is the x. The difference between them is 3 minus 1, which we're going to be 2. So as we can see, base is equal to 2. Base times our height, so base times height, which will going to be our c, our vertex, times 1/2, which should be the area. But then they gave us in the question, they said it is equal to 4. So we could say that in order to solve for height, if we simplify these expressions, we're going to get base, which we're going to be 2, times 1/2, times height, c, is equal to 4. So we could get that our c should be equal to either 4 or minus 4. The reason is because there is no negative. There is no negative in the area, so there can be either two number possibilities where the c value, our minimum point, can be either 4 or 4, -4. But if you think about what is the minimum, that means it should be the lowest. That means it should be lower than our two x-intercepts a and b. So obviously, if it is a 4, it is obviously higher than our a and b. So our conclusion will going to be our vertex. It will going to be -4. You can think about in this way. We know that our function is y. So for our basic binomial form, it will going to be y is equal to 8 times x squared minus 4x plus 3. And we converted this into a binomial form, which was y is equal to a times x minus 3 times x minus 1. So our ultimate question is to solve our a value, and we're going to solve for it through our vertex. And our vertex will going to be 2, -4. Not 2, -4, we're going to be x, -4. But we don't know our input value. If you know our input value, all you have to do is input it and input our output to our original function and isolate our value. But we have incorporated through our solutions that we talked about, our input in the vertex is same thing with the average between the two x-intercepts. And our two x-intercept is 3 and 1. All you have to do is our input x is same thing with the average between two x-intercept, which we're going to be 3 plus 1, and divided by 2, which we're going to give us positive 2. So basically our vertex, our total vertex will going to be 2 x value and the y value negative 4. So according to our strategy, where we input our vertex and isolate the a value, which will going to be the leading coefficient. If we input our x value as 2, or a positive 2, and our output negative 4 as the output, which is y, we're going to get, so if we input 2 to our original function, we're going to get y, but instead of y, we input negative 4. That is equal to a times, instead of x, we input 2 minus 3 times 2 minus 1. And if we simplify this, we're going to get negative 4 is equal to a times negative 1 times 1, so negative 1, which will going to be 4 is equal to negative a, and negative 4 is equal to negative a. So basically, we could solve that our a value will going to be a positive 4. So our answer for this question is a value will going to be positive 1. But not positive 1, positive 4. So if you review what we did here, firstly, we talked about our 3 solutions to solve for a question, since we knew that we're trying to solve for the leading coefficient, our leading coefficient a, which when the area of the triangle ABC, where it is formed by point A, B, and C, becomes 4. So firstly, we talked about the types and definition of vertex and quadratic function. Secondly, we talked about general types, 3 types that were standard binomial and vertex form, and what it is optimized for. And lastly, we actually inputted, or we applied our 3 solutions to solve this question, and we got our answer that a value, our leading coefficient. So a was the leading coefficient. And if you think about what this leading coefficient does, it defines our types of vertex as well as the graphs. And our a value in this case became positive 4.